Hello class, this is Mr. Sutton, and today we're going to be talking about simplifying rational expressions and multiply and divide rational expressions. So for this one, this lesson is just using a bunch of things that you have learned before, just combining them in a new way. So there's not really many notes to go over. We're just going to go through a bunch of examples here. So one thing you need to remember for this lesson is your methods of factoring. You have your ACB tree for trinomials, difference of perfect squares for, that is, binomials, when you have two perfect squares that are being subtracted, and then GCF. Always look out for your GCFs when you're factoring, and we'll have lots of examples like that, like these in the problems we're about to go over. But just make sure you remember these three types of factoring. So simplify the following expression completely. The way we are going to do that is by factoring. We're going to factor the numerator, we're going to factor the denominator, and we're going to see if we can cancel anything out. So these are both trinomials, so we'll have to use an ACB tree to factor these. So for the numerator, if you remember the ACB tree, you take A, you multiply by C, and you want to figure out two numbers that multiply to give you whatever that number is, but add to give you your B value, right? So in this case, for the numerator, we have 1. A value is 1 times 27. So A times C is 27. And then the B value is negative 12. So we want to figure out two numbers that multiply to give us 27, but add to give us negative 12. So first thing I'm thinking, I know 9 goes into 27, so 27 divided by 9 is 3. So 9 times 3 gives us 27. And then if I make both of these numbers negative, then if I multiply negative 9 times negative 3, it gives me a positive 27, and then negative 9 plus negative 3 gives me negative 12. So that's going to be my two numbers here. Now, that tells us how we want to split up our middle term. So we have x squared minus 9, x minus 3, x plus 27. So now we can go ahead and factor by grouping. So I'm going to factor out an x out of the first two terms, and then I'll factor out a negative 3 out of the second two terms. And then I'm going to factor out this x minus 9 out of these two terms, so I'm left with x minus 3, and then the x minus 9. So this would be how the numerator factors. Let me put that over here. So now we got to figure out how the denominator factors. So once again, I'm going to do an ACB tree. A times C is 1 times 9, so that's 9. I'm going to figure out two factors of 9 that add to give us negative 10. So for this one, I'm thinking it would have to be negative 9 and negative 1. That's supposed to be a 1. Negative 9 times negative 1 gives me positive 9. Negative 9 minus 1 gives me negative 10. So now I'm going to split up my middle term like that. Factor out an x out of the first two terms. And then factor out negative 1 out of the second two terms. Then factor out that x minus 9. So I have x minus 1 times x minus 9, which is how the denominator factors. So now I have factored both the numerator and the denominator to come up with this. Now we want to see if anything cancels. So that means if we have the same factors on the numerator and the denominator. Because if I have like this right here, I see I have x minus 9 over x minus 9. If I were to write that separately, we know that that would simplify to just 1, right? So within this fraction, we can go ahead and cancel that out, because if it simplifies to 1, multiplying by 1, we know doesn't change our value. So we can go ahead and take that out, which leaves us with just x minus 3 over x minus 1. So this would be our simplified version. Now it's important to note you can only cancel factors like this. They have to be attached by multiplication, right, in order to cancel these. So, because the reason is we have opposite operations when they're attached by multiplication, because we're multiplying by x minus 9, we're also dividing by x minus 9. And multiplication and division are opposite operations. So you might be sitting here thinking, why can't I cancel these x's here? I have an x in the numerator and an x in the denominator. You can't, because the x's are not factors on their own. They're attached with this subtraction, right? It's the x minus 3 that is the factor, right? That is what's being attached by multiplication, but the x on its own cannot be canceled. If we had something like this, these x's you could cancel because they're attached by multiplication. These x's you cannot cancel because they're attached by subtraction. So make sure you are careful about your canceling and not just canceling things willy-nilly just because they're in the numerator and the denominator. Let's go ahead and look at another example. This one, I'm going to go ahead and factor the numerator. That's another trinomial you'll factor by ACB tree. So you should have gotten x minus 7 times x minus 4 when you did that. The denominator here, a little different. We have a binomial here, and we have some GCFs. So I'm going to first factor by a GCF. We can factor out a 2x squared out of both of these terms. So we'd be left with just x here, and then over here we'd be left with 8. And then sometimes you'll be left with now a difference of perfect squares over here, and then you might be able to factor again. In this case, x minus 8 does not factor again. So that is all we have here. And then that is all of the factoring we can do. We have x minus 7, x minus 4, 2x squared, and x minus 8. Those are all of the factors we have. None of these cancel. So look back at the question, simplify the expression completely if possible. This one, not possible to simplify any further. So this is the most simplified version of this. So let's go ahead and look at the next one. So here on the numerator, we have a difference of perfect squares. 64 is a perfect square. That is 8 times 8. So if you remember the difference of perfect squares, the way this factors is take the square root of this value. So that would be x, and that goes here and here. And then you take the square root of this value, which would be 8. It goes here and here, and then you put a plus here and a minus here. And that is how you factor the difference of perfect squares. And then the denominator is another trinomial that we factor with an ACB tree. So I'm going to go ahead and do that now. So you should have gotten x minus 8 times x minus 3 in the denominator once you factored. So now we have the numerator and the denominator completely factored, and I'm saying they have this factor in common, this x minus 8. So I'm going to go ahead and cancel that. So we're left with x plus 8 in the numerator and x minus 3 in the denominator. And one thing I want to point out is that this process is exactly the same as simplifying just numerical fractions. If I had this, how you would think about simplifying this is first you would factor this 15 factors to 3 times 5, and the denominator factors to 2 times 2 times 5. And then you just cancel out the common factors. You cancel out the 5s here, so then you're left with 3, and then 2 times 2 on the bottom is 4, right? The same exact process. You factor, cancel out the common factors, and then simplify. So now we're going to get into multiplying these rational expressions. So for this, what you want to do, when we multiply fractions, you usually multiply across the numerator and the denominator. You could do that first. You could go ahead and start multiplying, but you're going to end up with some very large values that you're going to have to factor and try to simplify later, because they do want this in simplest form. So what I would recommend doing is factoring now, and that is what I'm going to do. I'm going to factor now, and then we combine everything, cancel everything out, and then we can start multiplying. So that way, when we're done multiplying, it'll already be in simplest form. That makes it a little easier for us. So we're going to go ahead and start factoring. We have a difference of perfect squares here. So that's x plus 1, x minus 1. 1 is a perfect square. That's one that we sometimes forget, because 1 times 1 is 1. And then here we have trinomial. So this would have to be x minus 2 times x minus 1. Here we have a GCF example. GCF is x squared here. So you'd be left with x minus 2. And then another GCF here. GCF is 7. You're left with x plus 1. Okay? So now we can go ahead and quote unquote multiply across, but don't actually multiply anything out. Just combine these into one fraction. So x plus 1, x minus 1, multiplied by x squared, multiplied by x minus 2. We'll just leave it like this for now, because we don't want to create more work for ourselves. You can even reorder it in a way that you might prefer. I'm just going to leave it like this for now. But now we can go ahead and try to figure out what things we can simplify. So x plus 1, x plus 1, x minus 1, x minus 1, x minus 2, x minus 2. Then we just have this x squared and this 7. So we can leave those. X squared over 7. And you could leave it like that, or you could rewrite it to 1/7 x squared, maybe. Either of these would work. Okay, so this is the way I would recommend doing it. Factoring it, and then combine it into one fraction, then simplify. And then if you have anything left to multiply, some of these you might not. Like this one, we didn't have anything left over to multiply, so we just simplified it. But that is a lot easier than actually trying to multiply x squared minus 1 multiplied by x cubed minus 2x squared first, and multiply the denominator, and then from there trying to factor and simplify. You're creating a lot more work for yourself if you do it that way. So do it this way. And here we have another perform the following operation and expressed in simplest form. Question, this time we are doing division, which, if you remember the way we divide, let's say I have this 3/4 divided by 7/4. That the way we do that is we change the operation to multiplication, and we take the reciprocal of this. All right. So we go from division to multiplication, and then we take the reciprocal of this, and then 3 times 4. Or we might want to cancel these 4s first, and then we have 3 times 1 is 3, and then 1 times 7, 7. So we do the same thing for this. So I went ahead and rewrote it as a multiplication problem. 7x over x minus 8 multiplied by x squared minus 64 over x squared plus 4x minus 32. Now we can go ahead and factor like we did in the last problem. Now this problem is very similar to the last problem, so we can go ahead and factor. This is a difference of perfect squares. We did this one before, actually. 64 is 8 times 8, so x plus 8 times x minus 8. And then down here we have another trinomial that we'll have to do as an ACB tree. I'll go ahead and show this one as an ACB tree as well, just so we remember how to do this. A times C, 1 times negative 32 is negative 32. Factors of negative 32 that add to give you the B value, which is positive 4. So that would be one. And one thing to note is one of these factors has to be negative because we have a negative result here. And it has to be the smaller number that's negative because we have a positive B value. So I'm thinking this has to be 8 and 4, where the 4 is negative. So 8 times negative 4 is negative 32. 8 plus negative 4 is positive 4. So it would be x squared plus 8x minus 4x minus 32. Factor out x. We have x plus 8. Factor out the negative 4. You have x plus 8. Factor out the x plus 8. And you have x minus 4 left over. So our two factors are x plus 8 and x minus 4. So now we can go ahead and combine this in one fraction. 7x, one fraction. So 7x, x plus 8, x minus 8. And then on the denominator, we have this x minus 8 is one factor. So I'm going to put that in parentheses now. X plus 8 and x minus 4. Kind of going off the screen there. So now we want to see what cancels. X plus 8, x minus 8. So we're left with this 7x and this x minus 4 in the denominator. And then you don't have to, if there's nothing being multiplied here, you can go ahead and drop the parentheses and just leave it as x minus 4. And that would be your final answer for that one. And I think, oh, got one more. Okay. So, and this one is just, the only difference in this one is this has a lot more factoring that can be done. I believe this is just a little more complicated, but same idea. We want to factor and then combine into one fraction, and then we can go ahead and simplify. So for this first fraction, I'm going to go ahead and we have x, and then this x minus 4 squared, I'm going to separate to x minus 4 multiplied by x minus 4. That'll just make it easier for us to see what we can cancel rather than leaving it as x minus 4 squared. And then this we can factor to x minus 4 times x minus 1. And then here, I think we have a GCF of 6. So we'd have x squared minus 10x, and then this would be plus 9. So we're going to have to factor this trinomial here again. I'm going to save that for the next step. Don't try to do too much in one step, because then you'll probably get lost in there. So if you have to factor in multiple steps, please do that. And then down here we have a GCF of 6 again, maybe, and x. So that would be so that would be x squared, and then minus 13x, and then plus 36. So this is another one that we'll need to factor again in the next step. So I'm going to go ahead and rewrite all of this, and then we will go over factoring these two. So this one will have to be x minus 9 times x minus 1. And then this one would have to be x minus 9 and then x minus 4. All right, so now we can go ahead and combine these into one fraction. So the difference with these problems here in this last section on Delta Math, I believe, is these have multiple steps of factoring compared to the other ones all seem to have one step to factoring. So the x's, you can cancel. X minus 4, x minus 4 here, another x minus 4, 6, x minus 9, and then x minus 1, and it looks like everything canceled. So what that means is we're left with just 1, right? If everything cancels, like if you have 5 over 5, those cancel, you're left with just 1. So don't get confused by that. Some people are like, oh, everything's gone. That means it's 0, but it's not. It's actually 1. Because if there were a 0 here, then this would all be 0 to begin with. But that's not the case. Everything canceled, so we're left with just the invisible multiplied by 1. So that is our final answer for this one. And this is the last problem. So if you have any questions, make sure you ask me during class, and have a good day.